In today's question, we are going to study questions based on force experienced on charged particle, moving charged particle in external magnetic field and Lorentz force. In this question, a charged particle, an alpha particle, is moving with a speed of 10 to the power 5 meter per second at an angle 30 degree in an external magnetic field of 0.8 Tesla. Force experienced by a charged particle in external magnetic field mathematically is expressed as F equal to Q into V into B sin theta. Substituting, charge on alpha particle is twice the charge on an electron. So if alpha is equal to 2e, charge on an electron is 1.6 into 10 raised to minus 19. Upon simplification, the final answer will be force experienced by charge is 1.28 into 10 to the power minus 14 Newton. Pause. Okay. In the next question, we are asked to calculate the ratio of kinetic energies for charged particles which are accelerated with constant difference. We have three charged particles: proton, deuteron and alpha particle. The ratio of the kinetic energies accelerated with the same potential difference or same potential in uniform magnetic field is given by. To solve this, we need to know what are the magnitude of charges for proton, deuteron and alpha particle. Magnitude of charge for proton is 1 electron charge of 1 electron. Magnitude of charge on deuteron is also 1 electron. Magnitude of charge on alpha particle is 2 times the charge on electron. And we know that kinetic energy, when accelerated with some potential difference, it is given by W is equal to Q into E. Therefore, kinetic energy is proportional. Kinetic energy exerted or exhibited by the charged particle is directly proportional to magnitude of charge. Therefore, the ratio of the charges is 1:1:2. Therefore, the ratio of kinetic energies of proton to deuteron to alpha particle is 1:1:2. In this question, we are seeing the ratio of radii traced by proton, alpha particle and deuteron when it is moved in external magnetic field with same kinetic energies. To solve this, we need to know the expression for radius in terms of kinetic energy, where the expression is R equal to under square root 2 mk divided by Q into B. It is accelerated with the same kinetic energy. All the charged particles have same kinetic energies, but the masses and charges of proton, alpha particle and deuteron are different. Mass of proton is m, mass of deuteron is twice the mass of proton, and mass of alpha particle is 4 times the mass of proton. So we are supposed to compare. Let's keep this equation of radius of proton in order to take the comparison. Let's keep this expression as it is. Rp is equal to root 2 mk upon Q into B. Mass is m and charge is Q. Mass of deuteron is 2 times the mass, so the mass will become 2m and charge is Q. And mass of alpha particle is 4 times the mass of proton and it is 2 times the mass of proton. And it has 2 times the charge of proton. Simplifying this, taking root 2 outside, so that we have root 2 mk upon qb. Here also taking root 4 outside, we'll have 2 into root 2 mk upon q into b. 2 will get cancelled. Radius of proton is root 2 mk upon qb. Radius of deuteron is root 2 into 2 root 2 mk upon qb. Alpha particle is root 2 mk upon q into b. If ratios are taken, then we are asked to calculate the ratios of proton to alpha particle to deuteron. The radius traced by proton is same as that of radius of alpha particle, so the ratio will be 1:1, and radius of the path traced by deuteron is root 2 times the radius traced by proton and alpha particle, so the ratio will be 1:1:root. In this question, we are asked to calculate the ratios of time periods of proton to alpha particle to deuteron when these are accelerated with same kinetic energies in uniform magnetic field. Expression for time period is 2 pi m upon q into b. Mass of proton is m. Let's take mass of proton is m, deuteron is 2m and alpha particle is 4m. And charge of proton is q, charge of deuteron is 2q, charge of helium or alpha particle is 2q. The ratios of these, let's keep the first expression as it is so that we can have a good comparison. Time period is 2 pi m upon qb. Time period is equal to 2 pi into mass of deuteron is 2m upon q into b. Time period of alpha particle 2 pi into mass is 4m and charge is 2q. substituting. Writing the time period for neutron and alpha particle in terms of 2 pi m upon qb, we are taking 2 outside, so it will be 2 into 2 pi upon q into b. 2 and 4 will get cancelled. You'll have 2 into 2 pi m upon q into b. Time period of proton 2 pi m by qb. Time period of neutron 2 into 2 pi m upon qb. Time period of alpha particle 2 into 2 pi upon m into q. 2 pi m upon q into b. Now the ratio of proton to alpha particle to neutron. Proton is, if we take the ratios, 1 is to 2 is to, the ratios are 1 is to 2 is to 2. Important factor to note down is the expression for time period when charged particles are accelerated in uniform magnetic fields. T equal to 2 pi m upon q into b. And in this question we are asked to note or identify what is the magnetic polarity of the charged particle which enters the external magnetic field. We are allowing 4 different charged particles to enter the external magnetic field. Depending on the path traced by the charged particle, we are supposed to identify the polarity. The first charged particle is going to move upwards once it enters the external magnetic field. Second charged particle experiences no deflection. Third charged particle moves downwards or opposite to the direction of magnetic field. Fourth charged particle enters the magnetic field from opposite direction and it traces the path downwards. So the charged particle which moves above or upwards is a positive charged particle. The charged particle which moves downwards is a negative charged particle. So third charged particle is negative. The charged particle which does not experience any deflection and moves in a straight line is a neutral particle. The charged particle which enters from the opposite direction and moves towards downwards, so it is a positively charged particle. Right. In this question, we are asked to calculate the radius of charged particle which will form helical path and pitch of helical path. So the expression for radius of helical path is mv sin theta upon q into b. A proton traces helical path. So mass of proton is 1.67 into 10 to the power minus 27 and it is moving with a speed of 4 into 10 to the power 5. Charge of proton is same as that of charge of electron, which is 1.6 into 10 to the power minus 19. It enters a magnetic field of strength 0.3 Tesla. Sin theta, which is sin 60, it is making an angle of 60 degree. So root 3 by 2. Simplifying and getting the expression for radius of helical path, which will be 1.15 into 10 to the power minus 2 meter. Since the options are in centimeter, we are supposed to write 1.15 centimeter. Similarly, the expression for pitch, that is distance between first and next circular turn in helical path, is given by v cos theta into t, where t is time period of helical path or time taken to complete one circular rotation in helical path. The expression is 2 pi m upon qb. As usual, it is moving with a speed of 4 into 10 to the power 5. Cos theta cos 60 is 1 by 2 and time period, if we substitute and finally simplify, we will get the answer. After all the cancellation, the pitch is 4 centimeter. The distance between one circular turn and the next circular turn is 4 centimeter. 3 charged particles enter uniform magnetic field P, Q and R. We are supposed to identify the polarities of charged particles, which one is positive, which one is negative and which one is neutral. So the charged particle which moves towards the charged particle which moves towards in the direction of magnetic field is positively charged. So P is positively charged particle. The charged particle which moves away from the charged magnetic field is negatively charged particle. So R is negative. And the charged particle which moves with no deflection is a neutral charged particle. And we are asked one more question. What if charged particles moves exactly in the direction opposite to that of magnetic field? So the magnetic force experienced is given by Fm is equal to Q into V cross B. If a charged particle enters the magnetic field in the direction or opposite to the direction, if it moves in the direction of magnetic field, angle between V and B is 0. If it moves opposite to the direction of magnetic field, so angle between V and B is 180. If theta is 0 or if theta is 180, force experienced by the charged particle will be 0 and it will experience no deflection. In this question, we are asked to identify the path traced if a charged particle neither enters parallel or perpendicular to magnetic field. What is the path traced by the charged particle when it enters uniform magnetic field? If it neither enters parallel nor perpendicular to field, then it means that it is entering magnetic field at an angle of inclination or angle of declination. When a charged particle enters parallel to the uniform magnetic field, the path traced by it is linear because it experiences no magnetic force. When a charged particle moves or enters magnetic field in a perpendicular to magnetic field, or when it is moving perpendicular to magnetic field, that means it experiences magnetic maximum force, and the path traced by it will be circular. When the charged particle enters at some angle of inclination, the path traced by it is helical. It will have both linear component and circular component. And in the next question, we are asked to write the mathematical relation between radius of proton, deuteron, and alpha particle when it enters uniform magnetic field. Radius of deuteron is always greater. We have seen the relation. The ratio of the radius is traced is 1 is to root 2 is to 1 or 1 is to 1 is to root 2. We have already solved this in the previous questions. The radius traced by deuteron is greater than alpha particle and proton, but the radius traced by alpha particle is equal to radius traced by the proton. We can either write it as radius of deuteron is greater than rp equal to r alpha, or radius of alpha particle is equal to rp less than radius of deuteron. It actually depends, the mathematical relation actually depends on the type of option given, and we are supposed to select the right option. If two charged particles enter uniform magnetic field with the ratio of their speeds 1 is to 3, what is the ratio of their radii trajected if the path traced by both the particles is circular? We know that radius of circular path when it enters uniform magnetic field is r equal to m into v divided by q into v. R is proportional to v, so we are asked to calculate what is r1 is to r2. R1 is to R2 will be V1 is to V2. We are given the ratio of the speeds with which they enter the uniform magnetic field. V1 is to V2 is 1 is to 3. Therefore, ratio of the radii R1 is to R2 also will be 1 is to 3.